topic is KMT. Basically, what is KMT? Kinetic molecular theory. This was a theory that was given by some scientists. There were 5 scientists that have given this theory. Number 1 was Bernoulli. Number 2 was Clausius. Number 3 was Maxwell. And number 4, that is a Boltzmann. And number 5 is a van der Waals. Basically, this is a theory of the gas. We can say kinetic molecular theory. This is a theory of the gas. So these were the scientists that have given this kinetic molecular theory, KMT. So first of all, we will discuss about the postulates of this theory. What were the postulates? There were some postulates. Number 1, that was the gas can be in any atomic form. In any atomic form. How? Like for example, if we are talking about atomic, like atomic, diatomic and polyatomic. How? Atomic, for example, we are having C, carbon, after that argon and many other gases like atomic acids. If we talk about diatomic, like O2 and O2, N2 and many other gases, that will be in a diatomic form. In this first point saying that gas can be in any, we can say in any atomic form. So it can be in the atomic form, diatomic form and also in polyatomic form. Which will be the polyatomic form? For example, CH4, NH3 and many other. After that, second point, that was the molecule of same gas. Molecules of same gas are identical to each other. Are identical in size, shape and mass. Gas molecules can be identical to each other in the shape, in the size and in the mass. Number 3 point was the gas molecules. Gas molecules are far away from each other and occupy negligible volume when compared with the container of the gas. Which means that the gas molecules are far away from each other. Like they all are far away from each other. They are having means far distance in between them. So they occupy the negligible volume if we compare them with the container of the gas. Like if you are having container of the gas like this and having gas molecules, so these gas molecules, volume of these gas molecules will be negligible if we compare with the volume of the container. After that, fourth point, that is the molecule of gases are moving randomly but within the straight line. which means these molecules, gas of molecules, are three-dimensional. They can move in the x dimension or y or z, but they will be always move in the straight line. So the gas molecules are moving randomly but in the straight line. After that, the presence of pressure in gas molecules is due to the collision of molecules with themselves or with gas container, which means the presence of pressure. The pressure will be generated in the gas molecules because or we can say due to the collision of the molecules with themselves. We can say collision of the molecules with each other of the gas molecules or with the gas container. The pressure will be generated due to the collision of the gas molecules with themselves or with the gas container. After that, we are having another point in this, which means that the pressure is directly proportional to the number of collision of gas molecules. Number of collision of gas molecules. After that, we are having one point that all the collisions of gas molecules elastic in nature. What is mean by this point? That all the collision of gas molecules among themselves or the gas container is elastic in nature. What is mean by elastic in nature? Which means no loss of kinetic energy. Which means if the collision is occur and the pressure is generated with the collision is occur by the gas container or among themselves, they will be always in elastic nature. What is mean by elastic nature? That the no loss of kinetic energy will be there. If they are collide with each other, gas molecules are collide with each other, there will be no loss of kinetic energy. After that, we are having another point, that is the no force of attraction or repulsion among them will occur, or repulsion among them will occur in between the gas molecules. After that, we are having another point, that the kinetic energy of gas molecules, kinetic energy of gas molecules depends upon the absolute temperature. Depends upon the absolute temperature. When the absolute temperature will increase, kinetic energy will increase. What do you mean by that point? That the kinetic energy of the gas molecules is totally depend upon the absolute temperature, which means it is depend upon the temperature. Kinetic energy of the gas molecules depend upon the absolute temperature. What do you mean by absolute temperature? That start from the 0. When the absolute temperature will increase, kinetic energy will also increase. So we can say here that the kinetic energy is directly proportional to the absolute temperature. After that, last point, that is the gravity. Gravity is neglected in the gas molecules. There will be no effect of gravity among the gas molecules. Now after that we are having one equation that is called as a kinetic gas equation. Kinetic gas equation. This was given by Clausius. So basically he gave one equation that is the PV is equals to 1 upon 3 mnc square. What is mean by this equation? Pressure and volume is equals to 1 upon 3 third part of the, what is mean by m, that is the mass of molecule, mass of gas molecules. What is mean by n, number of moles of gas molecules. And what is mean by c, that is the root mean square velocity of gas molecules. Root mean square velocity of gas molecules. Now for example, we are having one container in it and having gas in it, gas molecules in it. So every gas, as before, first point I've discussed about, every gas is identical. So they will be having different speed obviously. So the different speed of the gas molecules will be found by the root mean square velocity of the gas, which means these are having different speeds, so these will be having different velocities, so that will be different velocity will be found by this one. So how we can find the root mean velocity of the gas molecules? That is c square, that is this one, c is equals to the n1 c1 square. N1 is the number of moles and c1, which means for example this one molecule, that is a n1, this one is a n2, and this is n3, so that is why we are writing n1 and c1 plus into n2 c2 square into n3 c3 square, and so on. How many, it depends upon how many molecules, velocity of the molecules we are finding, upon n, that is the number of moles. So that is the, we can find the root mean velocity of the different molecules. So that was the kinetic gas equation given by the Clausius.